All right, so the next question is a specialized version of that previous formula from question 6. Technically, it comes from taking the volume and introducing mass in another place, and then you kind of do it upside down, so it ends up putting density on the bottom of your formula. It's a little bit of a tricky process, so I'm gonna give you a formula that you can use. D for density here instead of rho now, I guess. It's interchangeable, I suppose. But we're looking at the density of the gas, pressure of the gas. So temperature is not necessary in this one. You do have to be careful because gauge pressures are not good. So we need to make sure we're dealing with absolute pressures. Densities are always absolute. There's no like partial density that we're looking at with these. So we have to remember to add the atmospheric pressure. Well, when it's atmospheres, it's just one. So Earth has one atmosphere, and so they just called it one atmosphere. So nice and easy on that one. And then same thing over here. To make this into absolute pressure, I need to add one atmosphere. And sorry if it's kind of small, but basically we just add one to those. And then I want to make sure I don't accidentally use the old numbers, so I'll mark them out. And then we can plug in. All right, so we want to find our corresponding information. It looks like our 5.31 atmosphere pressure goes along with the 1.32, not 1.33, 1.32 kilograms per cubic meter. Remember, water was like 1,000, right? So gases are typically much lower densities. All right, then the other one, we have the pressure. It's 3.43 atmospheres. And what we don't have is the density. All right, so look at our corresponding units. Atmospheres and atmospheres can cancel. We're going to get kilograms per cubic meter, which is what we're looking for. It's a proportion, so we can cross multiply. 5.31 times that density. We still don't really know what's happening. Then in the other direction, if we multiply 1.32 and 3.43, 4.5276. And then finally, to get the density by itself, we want to divide. And that's because it's small, it'll be 4 decimal places, 0.8527 kilograms per cubic meter.